Today we are going to learn about integrating knowledge graphs with RAG models. We'll explore the step-by-step process of combining these technologies to improve data retrieval and generation. Welcome to our exploration of integrating knowledge graphs with retrieval augmented generation, RAG, models. In this video, we'll delve into how these two powerful technologies can be combined to revolutionize the way AI systems retrieve and generate accurate information. We'll guide you through the essential concepts of RAG models and knowledge graphs, highlight the benefits of their integration, and provide a comprehensive overview of the techniques involved. Our goal is to equip you with the skills to enhance AI-generated outputs by leveraging the depth and accuracy that knowledge graphs can offer. Let's begin this educational journey. Retrieval augmented generation, RAG, models represent a significant advancement in AI technology, combining the capabilities of retrieval and generation to enhance data accuracy and relevance. At its core, a RAG model consists of two main components: a retriever, which identifies relevant documents from a vast corpus, and a generator, which uses these documents to produce informed and contextually accurate outputs. This dual approach allows RAG models to leverage a wealth of external information, making them incredibly effective for tasks requiring up-to-date or specialized knowledge. RAG models are widely used in applications such as chatbots, virtual assistants, and content recommendation systems, where the precision of information and user satisfaction are paramount. By understanding the fundamental workings of RAG models, we set the stage for exploring how integrating knowledge graphs can further enhance their capabilities. Knowledge graphs are structured representations of information that showcase relationships between entities, making them invaluable tools for understanding and utilizing complex data. These graphs are composed of nodes, representing entities, and edges, representing the relationships between them. This structure allows knowledge graphs to depict data in a way that is both intuitive and highly informative. One of the primary benefits of knowledge graphs is their ability to connect disparate pieces of information, providing a holistic view that is often inaccessible through traditional data structures. Applications of knowledge graphs are vast, spanning from search engines like Google's Knowledge Graph, to recommendation systems, and semantic searches. By organizing data into interconnected networks, knowledge graphs empower AI systems to perform more sophisticated reasoning and inference, ultimately enhancing the quality and depth of data analysis.
Integrating knowledge graphs with RAG models offers a multitude of benefits that significantly enhance the capabilities of AI systems. First and foremost, knowledge graphs improve data retrieval accuracy by providing a structured framework that helps identify the most relevant information. This ensures that the generator component of the RAG model has access to high-quality data, resulting in outputs that are both precise and contextually appropriate. Additionally, knowledge graphs facilitate a deeper contextual understanding by mapping complex relationships between entities, enabling RAG models to generate content that is not only relevant but also insightful. The seamless integration of knowledge graphs into existing systems allows for efficient handling of complex queries, making them an indispensable tool for applications requiring sophisticated data processing. Ultimately, the synergy between knowledge graphs and RAG models leads to the creation of AI systems that are more intelligent, reliable, and capable of delivering enhanced user experiences. Integrating knowledge graphs with RAG models requires a strategic approach that involves several key techniques and considerations. One of the primary approaches is data alignment, where the structure of the knowledge graph is mapped to the data retrieval mechanisms of the RAG model. This ensures that the information extracted from the graph is directly applicable to the generation process. System architecture also plays a crucial role in integration, as it must support the seamless flow of data between the knowledge graph and the RAG components. Challenges such as data inconsistency and scalability must be addressed to ensure the integration is both robust and efficient. Adopting best practices, such as maintaining up-to-date knowledge graphs and optimizing data retrieval processes, can significantly enhance the effectiveness of the integration. By understanding these techniques and considerations, we can create AI systems that leverage the full potential of both knowledge graphs and RAG models.
To illustrate the power of integrating knowledge graphs with RAG models, let's explore some real-world examples that have achieved remarkable success. One notable case is the use of this integration in online retail, where companies have harnessed the synergy to enhance product recommendation systems. By utilizing knowledge graphs to map product attributes and consumer preferences, retailers have improved the accuracy and relevance of recommendations, leading to increased sales and customer satisfaction. Another example is in the healthcare sector, where integrating clinical knowledge graphs with RAG models has enabled more accurate and timely diagnosis by connecting patient data with medical literature and treatment protocols. These case studies highlight the transformative impact of knowledge graph integration on business performance and user experiences. They also provide valuable lessons on overcoming challenges and identifying opportunities for future expansion in various industries. Integrating knowledge graphs with RAG models is not without its challenges. One of the most common issues is ensuring data consistency and quality, as discrepancies can lead to inaccurate outputs and undermine the reliability of the AI system. Scalability is another significant concern, as the integration must handle large volumes of data efficiently and effectively. To address these challenges, it is crucial to implement robust data validation and cleaning processes, ensuring that the information within the knowledge graph is accurate and up-to-date. Additionally, adopting scalable architectures that can accommodate growing datasets is essential for maintaining system performance. Continuous improvement, through regular evaluation and refinement of integration processes, helps identify potential issues early and ensures that the system remains adaptable to changing requirements. By strategically addressing these challenges, we can create integration solutions that are both effective and sustainable.
A wide range of tools and libraries are available to facilitate the integration of knowledge graphs with RAG models, each offering unique features and capabilities. Popular tools for knowledge graph integration include Neo4j, a graph database that provides powerful data visualization and querying capabilities, and Apache Jena, a Java framework for building semantic web and linked data applications. For RAG model development, libraries such as Hugging Faces Transformers and PyTorch provide robust frameworks for implementing and fine-tuning models. When selecting tools, it is important to consider factors such as ease of use, scalability, and community support. Open-source solutions offer flexibility and customization, while commercial options may provide additional features and support. Ultimately, choosing the right tools and libraries can significantly streamline the integration process and enhance the overall effectiveness of the AI system, ensuring that it meets the specific needs and objectives of the project.
In this practical demonstration, we will walk through the step-by-step process of integrating a knowledge graph with a RAG model. First, we'll set up the development environment, ensuring that all necessary tools and libraries are installed and configured. Next, we'll focus on data alignment, mapping the structure of the knowledge graph to the retrieval mechanisms of the RAG model. This involves defining entity relationships and ensuring that the data retrieved is directly applicable to the generation process. Once the integration is in place, we'll conduct thorough testing and validation to ensure that the system functions as expected, producing accurate and contextually relevant outputs. Finally, we'll explore optimization techniques to enhance system performance, such as fine-tuning model parameters and optimizing data retrieval processes. This demonstration provides a comprehensive overview of the integration process, offering valuable insights and practical skills that can be applied to real-world projects. As AI technology continues to evolve, new trends and innovations in RAG models and knowledge graphs are shaping the future of data retrieval and generation. One emerging trend is the use of hybrid models that combine multiple AI approaches, further enhancing the capabilities of RAG systems. Innovations in knowledge graphs, such as the development of more sophisticated data representation and querying techniques, are expanding the potential applications of these tools in areas like natural language processing and machine learning. The future of RAG models holds promise for more personalized and dynamic AI systems, capable of adapting to user needs in real time. These advancements are poised to impact a wide range of industries, from healthcare and finance to entertainment and education, offering new opportunities for research and development. By staying informed of these trends, we can anticipate and leverage the latest innovations to create more intelligent and effective AI systems.
In conclusion, integrating knowledge graphs with RAG models offers a powerful approach to enhancing the depth and accuracy of AI-generated outputs. Throughout this video, we've explored the key benefits of this integration, examined successful real-world examples, and provided a practical demonstration of the integration process. We've also discussed the challenges involved and the tools available to support effective implementation. We encourage you to continue exploring this exciting field and apply the insights and skills you've gained to your own projects. Thank you for joining us on this educational journey, and we look forward to seeing the innovative solutions you'll create. Until next time, happy integrating.